Today we start with a new chapter in physics for standard 9th, that is chapter number 7 as per Concise, that is reflection of light. The chapter reflection of light is divided into two parts. One is about the plane mirrors. So reflection of light through the plane mirrors is the first part, and then the next part is about reflection of light through the spherical mirrors. So we'll be having these two parts, and in fact in spherical mirrors there will be also the sign conventions, which will be having some numericals based on that. And yeah, this chapter mainly contains the most important part over here is the ray diagrams. So the ray diagrams which are there in this chapter are absolutely very important. So we'll be practicing certain ray diagrams over here, and accordingly you need to practice over as homework also properly, so that you understand the proper basics of ray diagram. So let's start with the chapter. See, so first part A is laws of reflection and formation of image by a plane mirror. Now, first of all, let's understand why do we see some object. Okay, like for example, I am able to see the wall, I am able to see the board. Yeah, I am able to see this because the light is falling on those substances and then it is reflected back and it enters my eye. So that's why the reflected of the light, that we are able to see something because the light is reflected back by the substance. In case there is any particular substance which does not reflect the light but it is allowed the light to pass through them, then that particular object becomes almost invisible. Like for example, the people who are wearing specs right now, can you see your lenses? Can you see the spectacle lenses? No, you cannot see the spectacle lenses because the light is not reflected back over there, but the light is allowed to pass through them, and because it is allowed to pass through them, that's why the spectacle के glass जो है, they are almost invisible to you because they are not allowing the reflection to take place through them. So this is one of the example which I can give you, or there may be so many different examples wherein the light is passing through, and that's why we don't feel that particular object is existing in between. And that is exactly what is there in certain mirror maze. The mirror maze will have a transparent glass in between, and you don't even know, and you dash against it. So that is because they are so well made that and so clean that you don't see any dust particles on that, and that's why you don't feel that there is a glass in between, and you dash against it. Right. So when a beam of light strikes a surface, a part of it returns in the same medium. So when a beam of light hits on a surface, a part of it is reflected back in the same medium. The part of the light which is returned into the same medium is called as reflected light. Okay, so the reflected light is that particular light which is returned in the same medium. So when the light hits the surface and it returns in the same medium, then it's called as reflection. Thus, we can easily define reflection as the return of light into the same medium after striking a surface is called as reflection. Okay, the return of the light into the same medium after striking a surface is called as reflection. The remaining part of the light is either absorbed if the surface on which the light strikes is opaque, or it is partly transmitted and partly absorbed if the surface is transparent. So if the surface is opaque, then partly it could be absorbed, the light will not be 100% will not be thrown back, but only maybe 80% is thrown back and 20% is absorbed. And if it is a transparent medium, then it will be absorbing a bit and it is passing it through, it is letting a certain thing to pass through. So that's why it is partly transmitted, that is passed through, and partly absorbed if it is a transparent medium. Surface, not medium. It is a reflection of light which enables us to see the different objects around us. An object is seen when light from it enters our eye. Okay, so yes, when the light from an object reflected enters on the eye, we are able to see that particular object. The luminous bodies which emit light by themselves are directly seen, but the non-luminous objects are seen only when they are reflected, when they reflect the light incident on them and the reflected light reaches our eye. So of course, if we see a tube light, the tube light is going to give the light directly. So we can see the tube light because it is emitting the light. We can see the sun, we can see the candle, but whenever we are seeing some another part which is not illuminating, like the moon, we are able to see the moon only because the sun rays have got reflected by the moon and we are seeing the reflected ray of the sun rays from the moon. That's why we are able to see the moon, because the light is being thrown on from the means it is transferred, or it is going to be reflected from the moon and reaches our eye. Different surfaces reflect light to different extent. A highly polished and silvered surface, such as a plane mirror, reflects almost the entire light falling on it. So you can see that this is a very smooth surface, that's why it is reflecting the light much more. Okay. Whereas if it is a rough surface, so then like my shirt is a rough surface, it is not a shiny surface, then it is not going to reflect the light much. So you can see that depending upon what kind of surface it is either going to reflect a much more amount of light or it will be reflecting only partly of it. The plane mirror, the mirror what we use, the plane mirror is the example which will be giving out the, or will be reflecting the maximum amount of light which is hitting on it, striking on it. So a plane mirror is made from a few thick glass plate. One surface of the glass plate is polished to a high degree of smoothness. This forms the front surface of the mirror, and the other, or a back surface, is silvered. The silver mercury, that is silver, mercury or some suitable material is deposited over it. So it is this way that the glass is formed by, suppose this is a thin glass, okay, this is a thin transparent glass. So if I want to make this into a mirror, I will first polish this part very smooth, okay, this will be very smooth polished. And this side, the back side over here, I am going to coat some silver material. It could be mercury, it could be silver, or any other material which is going to give you that particular opaqueness and also reflect the light. So that's why that will be, normally it is used as silver and mercury. The silver surface is further coated. उसके ऊपर क्योंकि silver coated है, silver coated को protection देना सबसे ज़्यादा है. That's why that particular silver coated is further coated with the material which will protect the silver part, so that there is no damage caused to the silver part. Any damage caused to the silver part, automatically that much area will not be reflecting. So the silver surface is further coated with some opaque material so as to protect the silvering on it. The two surfaces of the plane mirror are shown in the figure. The light enters from the side of the polished surface and is strongly reflected from the silvered surface. The coating serves as an opaque surface and it does not reflect the light. So we see that this mirror can be given as like this, where this is the glass one, and on this side there will be the opaque surface, that is the coating, which is over a silver coating or silvered surface, silver coat, and this side over here, this over here is the polished part. So this is the polished part. So these are the rays of light which falls over here, and after falling they are reflected back in the same medium. So this is how the plane mirror is going to reflect the light. The next we see is kind of reflection. Now there are two kinds of reflection. One is a regular reflection, another is an irregular reflection. Now the regular reflection and irregular reflection will depend upon the type of the surface. It is the type of the surface which is going to determine whether the reflection what we are going to receive will be a regular one or a irregular one. So let's see the example over here. Now suppose I got two objects. One object is a plane surface like this, or maybe a mirror or something like this, plane surface like this, and another surface is curved like this. Okay, this is the curved part over here. That could be seen that always the rays of the light which falls on an object are always parallel to each other. Okay, because the rays are coming from a very far off distance, like the sun is giving us the rays of light. It's such a far off distance that when you are going to see it, when it comes near the Earth's surface, they almost become parallel to each other because they are intersecting parallel lines. Where do they intersect? At infinity. So we consider the sun's rays to be at infinity. So that's why we will always consider that the rays of light coming from a luminous object will be parallel to each other. So if we consider this, these are the rays of light which are parallel to each other falling on this particular substance, right, which is the plane mirror. Similarly, there is a ray of light which is coming over here. This is falling on this surface, which is also parallel to each other. It will be seen that in case of a regular, this is a regular, so this is a plane mirror and this is a rough surface. Now this is a regular image or regular reflection, whereas this will be an irregular reflection. It will be seen that because this is a straight line over here, that's why all these rays will be reflected back in the same manner and they too will be parallel to each other. These three lines will also be parallel to each other. So the reflected light, if the reflected light from that particular object, if that is parallel to each other, then we say that the type of reflection over here is a regular reflection. Okay, so when the incident ray is always going to, incident ray means the ray which is falling on the surface, if that is always going to be parallel to each other. But if the reflected ray, that is the after reflection, the rays which are after reflecting, they are also parallel to each other, then we call that particular kind of reflection is called as a regular reflection. Whereas in case of rough surface, it will happen that this one, because it is coming here in a wavy form, so this is the slant area, so this is going to go this way. This one is like this, so it will go like this. This is going to go like this. So each and every case, you can see that they are going to go in different directions, and that's why they are not parallel to each other. The reflection will be such that the reflected rays will not be parallel to each other, but they are going to go haywire. And because they are going to go in different directions, you can say that these are irregular reflections. Now, irregular reflection, you can easily identify irregular reflection whenever you see any particular surface, and you can see that it is wavy or it is rough. You can feel that while touching. You may not know it, but while you can feel it. Yeah, it looks like a rough thing, right? It is basically because the light rays which are reflected from that particular part are coming not parallel to each other. Because they are not coming parallel to each other, that's why you can see them as a rough surface, or you can feel that they are rough surface. That's just called as an irregular reflection. So there are two kinds of reflection. They are following two kinds of reflection: regular reflection and irregular reflection. First, regular reflection. Regular reflection occurs when a beam of light falls on the smooth and polished surface, such as a plane mirror. In figure 7.2, a parallel beam of light is incident to a plane mirror. The reflected beam is also parallel and it is in the fixed direction. It can be seen only for a particular direction. So you can see that over here, you can see it only from this direction. That's why this particular thing is a regular reflection. An irregular reflection may occur when a beam of light falls on a rough surface, such as the wall of a room, a page of a book, or any other object. Although the wall of the room or page of the book appears to be smooth, but actually it is quite uneven, having many small projections over it. For example, in figure 7.2b, light rays fall at the different points on the rough surface, and each ray gets reflected from it, obeying the laws of reflection of light. So what is the law of reflection? I'll just explain you in a later part. But basically it will be such that the angle which this is forming, see over here, okay, I'll just explain you this thing. it is always this way that the angle which this makes with the perpendicular to this line. So this is called as angle of incidence and this one is called as the angle of reflection. Now the law of reflection says that angle of incidence is equal to angle of reflection. So that's why if these are parallel, these will also be parallel. Over here also if you see the angle of incidence will be equal to angle of reflection. Here also the angle of incidence over here is equal to angle of reflection. Here also the angle of incidence is equal to angle of reflection. But the point is that since this is wavy, therefore the reflected rays which are coming up are in different directions. Here, because this is a smooth surface, so all of them are perpendicular and that's why all the things are exactly parallel to each other, not perpendicular, parallel to each other. So in this way, you can see that even regular reflection, even in case of irregular reflection, the light rays does observe or obey the laws of reflection. So here also the angle of incidence is equal to angle of reflection, but the point is that because the surface itself is not smooth, that's why they are going to be giving you directions of the reflected ray in different directions. So the light falls on the different points of the rough surface and each ray gets reflected from it, obeying the laws of reflection of light. Due to uneven surface, at different points, light rays get reflected in different directions. Okay, because of the unevenness of that particular, you can see the wavy part. So uneven surface over here. So due to the uneven surface at different points, light rays get reflected in different directions and give rise to diffuse or irregular reflection. As a result, the reflected light spreads over a wide area and does not follow a particular direction. Thus, the reflected light can be seen from anywhere. It is a diffuse light obtained by reflection from various uneven surfaces which enables us to see the object around us. So, we are able to see the object around us because the light rays are coming in all the different going in different directions. That's right. Like for example, if I see a curtain, so curtain will be like this, curvy will be there. Okay, but we are able to see certain parts darker and certain lighter. Why? Because it is giving out light in all directions. So I can see the lighter part, darker part, सब कुछ मैं देख सकता हूँ because some area of the darker part also reflects the light which is falling on my eye. So that's why I am able to see even that darker part which is normally not seen in a smooth surface. So if a smooth surface, for example, if I got a mirror like one mirror like this and one mirror like this, can I see this mirror? No, I will not be able to see this because this mirror is reflecting light only on this direction. It will not be reflecting to me. So if it is a smooth surface, I cannot see it. Okay, so that's why it is the diffuse light obtained from reflection of various uneven surfaces which enables us to see the objects around us. Now we see some very important terms which are going to be used in reflection. So the terms which are used in reflection, let's do one by one. So if I draw a figure first, it will be this is your plane mirror. And firstly what we see is the incident ray. So any ray of light, a ray of light which is hitting or striking on the reflecting surface is called as the incident ray. So incident ray, all these definitions are very important. You need to learn them by heart. So incident ray, the light ray striking a reflecting surface, a light ray striking a reflecting surface is called as the incident ray. So the light ray striking a reflecting surface is the incident ray. Second is point of incidence. This is called as the point of incidence. So the point at which the incident ray hits the surface. So that's right. So it is the point at which the incident ray strikes the reflecting surface is called as the point of incidence. So this is the point of incidence over here. This point of incidence is the point at which the incident ray strikes the reflecting surface. The next one is called as the normal. So this is the normal. The normal is the line, a imaginary line which is drawn perpendicular to the surface at the point of incidence. Okay, at this point of incidence, if I draw a perpendicular, which is an imaginary line, okay, I cannot see it, but this is the imaginary line which I can draw perpendicular to the surface at the point of incidence, is the normal. So normal, oh I missed one, no anyway, fourth, I just came to the fourth one, we'll go to the third one, next one. The perpendicular drawn to the surface at the point of incidence is called as the normal. So perpendicular drawn at the point of incidence to the surface at the point of incidence is called as the normal. Then comes the reflected ray. So reflected ray will be over here, reflected ray. So the ray of light, which is after reflections, okay. So the light ray obtained after reflection from the surface in the same medium in which the incident ray is traveling is called as a reflected ray. So this is the reflected ray, that is nothing but the light ray, the light ray obtained after reflection from the surface in the same medium. Yeah, that's very important, that it should be in the same medium. Same medium in which that incident ray is traveling is called as the reflected ray. The next we see is the fifth one, which is angle of incidence. So this over here, the angle between the incident, so this is the incident ray, this is normal, this is reflected ray, okay, this over here is point of incidence. Now we move to I, which is angle I is equals to angle of incidence. What is that angle? That is the angle between the normal and the incident ray at the point of incidence. Okay, so the angle which the incident ray makes with the normal at the point of incidence is called as the angle of incidence. It is denoted by letter I. So angle between the incident ray and the normal at the point of incidence is the angle of incidence. Similarly, this over here will be the angle of reflection. So the angle between the reflected ray and the normal at the point of incidence is called as the angle of reflection. Angle of reflection. Reflection. So that was angle of reflection, the angle which the reflected ray makes with the normal at the point of incidence is called as the angle of reflection. It is denoted by the letter R. So it is letter R over here. Then comes the plane of reflection. So if we see, then it will be like, okay, I'll just show it this way. This area over here, normal के ये side के वाला part है, that is the plane of incidence. Okay, whereas this part over here, normal के ये side वाला reflected ray वाला part is plane of reflection. Okay, so that is the plane of incidence and this is the plane of reflection. So we have the plane containing the incident ray and the normal. The plane containing the incident ray and the normal is called as the plane of incidence. The plane containing the reflected ray and the normal is called as the plane of reflection. Okay, so these are the two planes, incident plane and the reflected plane. Now, in figure 7.3, M dash is the mirror. So this is given as M dash. This is the point O, which is the, this is O. Then this is named as A, this is N, and this is R. Okay, B, sorry, this is B. So it is given that in the figure MM1 or MM dash, whatever, is the plane reflecting surface, as the plane mirror, kept perpendicular to the plane of the paper. A light ray is incident in the direction AO at the point O on the mirror. It is reflected along the direction OB Thus AON is the incident ray, O is the point of incidence, OB is the reflected ray. Okay. AO is the incident ray, O is the point of incidence, OB is the reflected ray. Let ON be the normal, so ON is the normal over here, or perpendicular drawn to the surface MM dash at O. The angle AON is the angle of incidence, which is the angle incident ray makes with the normal, the angle of incidence, and angle BON, which is reflected ray. So BON, which is the angle made by the reflected ray with the normal, that is the angle of reflection. The plane of the paper is the plane of incidence. So you can see this is the plane, the paper is a plane of incidence. Okay, now let's understand the laws of reflection. A light ray obeys the following two laws of reflection from the surface, which is called as the laws of reflection. First one, the angle of incidence is equal to the angle of reflection. So the first thing over here is the angle of incidence. So this is the first law, is angle incidence is equal to angle of reflection. This is exactly what we saw over here also, that this ray over here, this was like this. So perpendicular उसका यहाँ पे है, इसीलिए ये जो angle बना है वही angle इससे बना है, इसीलिए it went in this direction. Here this is like this, so the perpendicular is like this. So इसका ये angle और ये angle equal है. Here it is like this, so the perpendicular is like, so sorry, the plane will, okay, this will be slightly different. So the plane is going to be like this, and accordingly it will be this way and this way. So you can see that, and here also the law of reflection was obeyed. So similarly, what is the law of reflection? First law is that the angle of incidence is equal to the angle of reflection. So for any particular incident ray, the reflected ray will always be such that the angle of incidence is equal to the angle of reflection. It is irrespective of what kind of surface it is. It is a rough surface or smooth. I told you about the rough surface also. It was giving the same laws of reflection. So the angle of incidence is equal to the angle of reflection. Second is, the incident ray, the reflected ray and the normal at the point of incidence lie in the same plane. So you can see that all these, incident ray, normal, reflected ray, all lie in the same plane. Because they are in the same plane, I am able to draw it over here. I don't need to share that, अगर ये ऐसे आएगा तो ये ऐसे बाहर निकलेगा. Do I need to say that? No. I could easily draw it over here. Because I was able to draw it over here, that's why it is in the same plane. So we can see that the incident ray, the reflected ray and the normal lie on the same plane. So these are the two laws. So the first law is angle of incidence is equal to angle of reflection, and second is incident ray, reflected ray and normal lie on same plane. Okay, they lie on the same plane. So these are the two laws of reflection. What are the two laws of reflection? That angle of incidence is equal to angle of reflection. Second, the incident ray, normal and the reflected ray, all three lie on the same plane. So we see that reflection of a ray of light normally incident to a plane mirror. So you can see that if a body is such that it is at this point and the ray of light is falling like this, perpendicular, what will happen? The angle of incidence is equal to 0, because what is the angle of incidence? It is with the normal and the angle of the reflected incident ray. Because normal and incident ray are the same, therefore angle of incidence is 0, so the angle of reflection will also be 0, that's why it will be returning in the same path. So this point over here, from here, the ray of light is going also in the same direction and coming also in the same direction. So that's why for a ray incident normally to a plane mirror, the angle of incidence I is equal to 0, therefore angle of reflection R is equal to 0. Thus a ray of light AO incident normally to a mirror is reflected along the same path OA. It traces its path as shown, so that will be this way, that it goes also this in the same manner and comes back in the same manner. So sorry, goes down in the same manner and reflected also in the same manner. So that is about the angle of reflection is equal to angle of incidence. Sorry, angle of incidence is equal to angle of reflection, and that's why the light normal to the surface will always travel back in the same direction. Now we see the experimental verification of the law of reflection, but in the next video.